Welcome to the Titus webcast discussing a valuable tool in the heating, ventilation, and air conditioning designer toolbox, the Variable Geometry Diffuser. Today, we will discuss where these devices are valuable, some types that are available, and some design considerations when implementing variable geometry diffusers. I'm David Zimborski, the product manager for terminal units, which includes VAV Diffusers. I'll be your presenter today. To familiarize our audience with variable geometry diffusers, we will break a broad subject into smaller pieces. First, we'll talk about concepts and benefits. Next, we'll look at how they are made. Third, we'll discuss how to apply variable geometry diffusers. After this, we'll see how using variable geometry diffusers affect a system by looking at the benefits and design criteria. Variable geometry diffusers can have different uses. Today, we will talk about the diffusers that vary their geometry in order to vary the volume of air delivered. This will distinguish them from variable geometry diffusers that adjust the throw pattern or for other purposes. Varying the amount of air is desirable for controlling ventilation and temperature in the occupied space, and this leads to greater occupant comfort. Let's look at a standard fixed geometry diffuser and compare them to variable geometry diffusers. Sometimes variable geometry or VG diffusers are referred to as variable air volume or VAV diffusers because they have some similar functions as traditional VAV units used in modern HVAC installations. Varying the geometry varies the volume of air the diffuser delivers. When we need to modulate air delivery to a space, specifically lower the amount of conditioned air delivered, a traditional fixed diffuser can be controlled by a traditional VAV terminal. When this happens, the airflow, discharge velocity, mixing, and throw distance will all decrease. If it decreases too much, unacceptable performance, such as dumping, can occur. Dumping is when a cool air drops only in the vicinity of the diffuser and does not circulate throughout the space. Conversely, if the diffuser is used for heated air, without proper mixing, uncomfortable stratification can occur. When a VAV diffuser is used to decrease the airflow, the discharge velocity and mixing remain equal to standard diffusers over a much broader range. The throw distance will go down slightly, but not as much as a fixed diffuser. Another behavior of a variable geometry diffuser is that it changes the throw pattern as the geometry changes. When the diffuser is fully open, air is distributed in a nice radial pattern. At 50% opening, the pattern is still mostly radial. At the minimum opening, the discharge is a cross-flow pattern that still delivers good mixing in the space because of the increased discharge velocity. The benefits to using variable air volume diffusers are several. Installation is easy and straightforward. They can be even quickly installed as a field retrofit for applications where additional control is desirable. VAV diffusers can be mixed with standard constant air volume or CAV diffusers in the same installation. They can have similar performance as well as aesthetics. VAV diffusers can work well at lower pressures, allowing system fan energy savings. Because the variable geometry keeps velocities higher, cold air dumping or hot air stratification is avoided. There are two general technologies for variable air volume diffusers: thermally actuated and electronically actuated. Let's look at the first system to be developed first. Thermally powered VAV diffusers use a plaque mounted mechanism that allows the diffuser to look almost identical to standard diffusers. They are used to maintain a relatively constant space temperature by automatically modulating the opening to modulate the delivered air. The tightest thermally actuated diffusers are auto changeover devices for systems that deliver either cooled or heated air. Here is an exploded view of a thermally actuated VAV diffuser. Starting from the bottom up, which is the portion closest to the space, we first see an induction cap. This device draws room air into the actuator to compare to the conditioned air. The temperature differential tells the device what to do. The cap fits into the face plaque. The face plaque operates as both a diffusing mechanism and an aesthetic part of the diffuser. The induction channel delivers room air into the temperature sensing mechanism. The Venturi tube uses delivered air pressure to create suction that draws room air into the actuator mechanism. The control disc moves up and down to modulate the effective opening of the diffuser. This movement is what varies the geometry and, therefore, the volume of the delivered air. The thermal actuator uses a temperature-sensitive material to move the control disc up or down. Through expansion and contraction of the material, a mechanical motion is proportional to the temperature difference in the space and the delivered air. Finally, the back pan is very similar to a traditional diffuser in that it connects to the supply duct and carefully spreads supply air throughout the diffuser for optimum flow. This is a photograph of the Plaque Assembly. This subassembly is shipped pre-assembled to minimize installation time and cost. Here, we are looking at the actuator mechanism in more detail. A temperature-sensitive wax element is used to expand and contract. It's magnified by a mechanical advantage mechanism to balance spring pressure and create movement. In the cooling mode, as the wax is heated by a warm room, it will expand to push open the control disc. As the room is cooled down, contracting wax will shrink, allowing the spring to return the mechanism to a more closed position. This cycle is automatic and needs no external input. The automatic changeover versions, additional hardware in the actuator will reverse the movement when the temperature difference between the room and the supply are reversed. Here we see the mechanism with an adjustable ring. The room temperature setting is adjusted for both heating and cooling modes with only two settings. First, the cooling temperature is set by adjusting the top ring, which is blue in this drawing, to the desired cooling temperature. Next, the offset between heating and cooling set point is set on the lower ring, red in this drawing. The offset can be up to 4 degrees in either direction. For example, if the desired cooling air temperature is 72 degrees, a 4-degree offset would make the heating temperature 68 degrees. The larger gray ring sets the minimum opening to maintain proper ventilation. Since this mechanism is in the ceiling, it is typically adjusted at installation only. A further limitation of thermally actuated mechanism is that the dead bandwidth, that is, the difference between full on and full off, can be wide. This means that there can be perceptible temperature variations in the space. The advantage of the thermally actuated mechanism is that they require no power and are fairly reliable. They provide limited automatic modulation for small spaces with minimal hardware and cost. They have no external components like a thermostat, so installation is extremely simple. Let's talk a little bit about how a mechanism surrounded by supply air measures room air temperature. The Venturi tube, to the right of the central actuator in this drawing, takes supply air at delivery velocity. It throws the air through the induction channel into the space. The velocity of exiting air creates a slight negative pressure that draws air from the conveniently located induction cap, located in the bottom in the center. This room temperature air is forced up into the actuator mechanism to cause the thermal expansion and contraction that creates the motive force of the actuator. Let's look at the electronic diffuser now. In order to add features, an electronically actuated variable air volume diffuser was developed. Using modern and cost-effective electronics, several advantages are now available to the system designer. The advantages of electronic VAV diffusers are greater occupant comfort due to operator and occupant adjustability, ability to connect to remote temperature sensors, the ability to connect to local systems using primary and secondary configurations, the ability to communicate with building-wide control systems to optimize and economize performance, and the ability to add local reheat when needed. Simple plug-and-play electronics make these installations quick and easy. The connection of each individual unit can be only to a local thermostat. For more sophisticated systems, several diffusers can be networked into a building management system. Let's look now at the electronic variable geometry diffuser parts. The plaque, control disc, and backpan are equivalent to the older thermally actuated device. What is new is the control board, the mechanical actuator, and the communications module. The control and communication modules are made from robust, compact, and cost-effective modern electronics. The mechanical actuator uses a very special motor and gear mechanism to mechanically raise and lower the control disc. When several VAV diffusers are used together in a system, an interface box supplies additional power and allows communications to a central unit if desired. The connectors are separate styles that are not interchangeable to make installation virtually foolproof. Wall sensors are connected to a simple RJ12 modular connector, similar to traditional phone system connectors. The power supply is connected with a 4-pin mini-fit connector. Daisy chaining these can connect up to 16 devices to one power supply. The ribbon cable is connected to the diffuser to supply both power and communication. Finally, the optional changeover sensor is connected with a single pair wire to allow automatic changeover in systems where it is desired. With electronic VAV diffusers, a wall-mounted room sensor is used for several purposes. Connecting a wall sensor to a diffuser allows the combination to control one or more remote diffusers in a larger space. The sensor also has traditional programmable thermostat functions for occupant control and comfort, as well as energy savings. Additionally, the wall sensor can be used as a communication port that is more convenient than the master communications module, which may be in the ceiling. Using the wall sensor as a communication port greatly simplifies installation and troubleshooting. Power supply modules are available in 3 different voltages and supply the low voltage control power to the system components. Again, distinctive connections simplify system assembly. The cable to the master communications module is an RJ9 style cable to keep it distinct from the communications between the wiring interface box and the wall sensor. The power to the wiring interface boxes uses the 4-pin mini-fit connector. 2 connections can power up to 15 devices total. The master communications module is used when larger systems are to be connected. These systems can act in a coordinated fashion as standalone systems. Alternatively, they can be connected to a larger building-wide management system using the industry-standard BACnet protocol. Each module can connect up to 15 modules in each of its 4 channels, which means that up to 60 diffusers can be on one module. Each diffuser communicates room and supply temperature, flow rate, nightly setback, and control disk position. This is an example of a standalone system wiring architecture. We have 2 spaces with 2 diffusers in each. Each space has 1 wall sensor. If we change our space, for example remodeling and adding walls, the existing controlled units can be given their own wall sensors to make them fully independent diffusers. To take the original system and allow it to communicate locally or with a building management system, or BMS, we only need to add a communications module. Electronic VAV diffusers can be interconnected and scaled to make larger systems. Larger systems can be constructed by linking up to 15 individual diffusers or thermostats to one interface box and up to 4 interface boxes to one communications module. This means that one communications module can handle up to 60 diffusers. By connecting the communication module to a building-wide system, full transparency and control can be realized. For some locations where supplemental heating is needed, an optional duct heater is available. This option is only available with electronic units. Each heater requires its own high-voltage power supply. The heaters are capable of full integration in the BMS system, including monitoring and even submetering if desired. These heaters are used for reheating conditioned air when needed to improve occupant comfort. These heaters are intended for trimming room temperatures or to provide limited heating in low-flow applications. If building primary heat is needed, additional heat sources would probably be needed and supplied by a central air handling unit. Let's now turn our attention to how variable geometry diffusers can be integrated into an air delivery system. VAV diffusers can be used either as part of a complete VAV diffuser system or as part of a conventional duct with fixed diffusers for finer control of smaller subsystems. When used this way, as a problem solver, we recommend limiting variable diffusers to about 30% of the airflow. If they are used for more, some sort of bypass or primary air volume modulation might be needed. When used as a standalone modulator, traditional static regain design rules apply. The static regain ductwork design method has been the choice of engineers for many years, even though it is more difficult and time-consuming than the equal friction technique. Static regain designs have been attributed to yielding more balanced systems that have better flow characteristics than equal friction systems. However, the equal friction method can provide equally efficient designs when experienced engineers use careful initial design assumptions. When a variable air volume or VAV diffuser is used on a single duct branch, a VAV box is not needed. The first method we will discuss to regulate pressure is a simple method that allows pressure control locally at a variable air volume diffuser. It is a pressure relief ring just before the diffuser. This is a simple and reliable device, but also provides lower system efficiency. When the variable air volume diffuser closes, the excess air simply blows out of the opening between the duct and the diffuser. In order to control airflow in the space, duct pressure must be controlled. Another simple method is to use a fixed-speed fan and to couple this with a pressure sensor and dump valve. The pressure in the duct can be controlled using face and bypass dampers or if carefully selected, a bypass damper only. The face damper will allow enough air through to maintain the required pressure in the ducting. The bypass damper will bleed off excess pressure to the return air side of the air handling unit. This also is a less than ideal duct design because it uses high fan energy, and the conditioned air is not all being delivered to the space. An alternative to dumping treated air into the plenum would be to control the volume of air at the air handler by using dampers. This is generally low cost, but also lowers efficiency. To increase efficiency, the bypass should be ducted directly back to the return. A series of variable air volume diffusers can also be controlled in a more traditional and efficient manner using a single duct run supplied by a VAV terminal unit. A static pressure sensor is a simple way to control the total volume of air to the duct run. This is more efficient than the previous methods, as all the conditioned air is delivered to the occupied space. A few considerations to keep in mind when designing systems with variable air volume diffusers are: first, variable air volume diffusers operate at low pressure. Second, variable diffusers can be used to complement traditional systems, leading to additional flexibility. Third, VAV diffusers can make a small standalone system that has some advantages over traditional VAV boxes with fixed diffusers. In the next slide, we will see some of the possible advantages with VAV diffusers. The first advantage that variable air volume diffusers can have is that they can require less ductwork. This shows also that variable air volume diffusers can be used in a retrofit application to increase occupant comfort while lowering operating cost, as long as the air supply can be modulated. Lower first cost and reduced installation space can lead designers to VAV diffusers. Remember this layout as we look at a conventional system on the next page. As we see here, a comparable VAV box system with fixed diffusers might require more hardware, leading to a slightly higher installation cost and slightly greater space requirements. A slightly more sophisticated VAV diffuser system is shown here. Using electronic VAV diffusers in the space provides the most accurate temperature control. Using secondary and primary diffusers lowers the material cost and installation time. Finally, a variable speed fan air handler with downstream pressure sensing modulates the supply air so no dumping occurs. This type of system can be very cost-effective with good performance for small and medium-sized installations. Larger systems can be designed using VAV diffusers as long as some additional hardware is included in the system. Here we see a similar but larger system. The difference here would be a more sophisticated duct design with more pressure sensors and pressure control dampers to control the airflow within the system. Variable air volume diffusers are also available in a linear format. These can be either electronic or thermally actuated. Linear slot diffusers have an additional consideration in that the variable geometry can be used to change the volume of airflow. Linear diffusers are often used for perimeter applications with higher external heating and cooling loads. In addition to adjustable throw patterns, other options are available. Inlet heaters can be used in a cooling-only system to do zone tempering. Various mounting options are available for different sealing surfaces and architectural effect. These drawings show the advantages of using two slot diffusers. The discharge can be set to right, left, both, or down. This also simplifies ordering and installation, as the two slot units do not have a handedness when ordered or installed. Linear slot diffusers are often used in private offices, conference rooms, and medical spaces, especially in perimeter applications. Because of the directional discharge, linear slot diffusers can be very effective when large windows create external heating and cooling loads. Where would variable air volume diffusers be used? They can be used in large new construction projects or as a smaller finish-out work to provide additional local control. They offer one additional way to provide control and increased occupant comfort. Sometimes they can provide a solution for a local problem, such as a conference room or other rooms with highly variable use. They also can be a good solution for entire spaces when combined with controlled air systems. This leads to a good question of what are the limitations of variable air volume diffusers. VAV diffusers work well for smaller installations or smaller subsystems in installations, but can have a limited range of operating conditions when compared to the variety available with traditional systems. Also, varying the geometry can vary the sound generated by the diffuser. The thorough designer will check the range of temperature, airflow, and sound levels when choosing a VAV diffuser system. Variable air volume diffusers provide additional solutions for the heating, ventilation, and air conditioning designer. With the flexibility of modulating air, they can improve occupant comfort while keeping equipment and installation costs reasonable. With square and linear diffusers, more architectural options are available. Finally, with electronic control, full integration with the building management system allows integration with an efficient and sophisticated system that maximizes indoor air quality while reducing operating costs. VAV diffusers can be part of an optimal comfort solution in heating, ventilation, and air conditioning systems. Combined with some of the many other HVAC components available from Titus, the system designer can deliver a high comfort, high efficiency, cost-effective solution to the building owner.